Hello class, today I'm going to talk about parameters, how to assign parameters, how to work with parameters in ANSYS. Let's open Workbench and use parameter option in our design. How parameters can help us? Instead of changing different for example, dimensions to check one parameter, for example, it can be a stress or strain, anything else, or mass. ANSYS can automatically do that job for us and just do all the change and give us the effect or output parameters which we selected, the effect on the output parameters. So statistic structural as usual. Let's select AP02. I'm not going to change the data. The material properties, structural still would be our material, and it is the default material. I'm opening geometry to open the space claim. Great, we have a space claim. I would like to draw at XY surface. So XY surface selected, the vertical view, rectangle 200 millimeter by 200 is good enough. Let's pull it. 5 millimeter is good. Now I would like to draw a circle. Oh, I haven't selected. See, the cursor doesn't have a plus sign, which means I can't draw circle right now. I selected the drawing plane, so I can now start drawing. I would like to draw a circle 5 millimeter away from that top part, and the diameter is going to be 4. Okay. How I can draw another circle here or copy this one? For copying this circle, this time I'm going to use move tool. So I selected this move tool, clicked over the circle, and move tool is over that circle. I'm going to click control button and drag this red one. What is the distance? Let's have 10 millimeter. Good. Now let's pull and extrude this one. Select this circle, control, select the second one. Now you can drag. 20 millimeter would be good. Now let's complete the top part. I'm going to draw a rectangle here. Vertical view. Rectangle who can cover the whole circle. Let's pull this. But I want to pull these two circles and the area between. So I'm using control button to select all those 3 areas without the area around that circle. So I can easily pull. 5 millimeter would be good. So as you can see, we have an extra surface here which we need to get rid of it. We go to structure, the tree, the design structure, and the surface. We can right click and delete the surface which we don't need it. Now we need to have some parameters for our design. How we can select that parameter? Just simply click over the cylinder. You can see a P here close to the dimension or radius of the cylinder. Select that P. Automatically the color changed to gray, which means we select it as a parameter. Go to the next one, select this P, and parameter is selected. Let's go and check the groups here. We have two parameters selected as a group 1 and group 2. Let's rename it. This one I'm going to call top for top cylinder, and bottom cylinder, both 2 millimeter radius. Okay, let's go back to our design. Oh, I need to update this geometry because it doesn't have green check. Now you can see the parameter section added to our analysis. There is a arrow in one side, which means we have some parameters to give input but not output. So later we need to select those output these parameters too. I'm opening model section. It takes a bit time to import our drawings. Okay, now let's see what we have. For mesh, I'm going to generate the default mesh. It's very rough. To improve the quality of mesh, instead of using different mesh tools, I'm just using relevance center instead of having coarse. Let's go for fine mesh. Let's update this one. Much better mesh quality can be seen for the new one. So support, fixed support here. Let's apply that one, and I would like apply a force downward at this surface. Force here, apply, and I want to have a components because it should be negative, for example 200 Newton, to be at the direction of y-axis but downward. That is why I added negative. For solution, deformation and stress is enough for us. Okay, we can see the stress, maximum stress here, at the top here, and a little bit here. Okay, now we need to select output parameters. One of the, because input parameters was the diameter of these two cylinders, one output can be mass. So I select geometry to find mass, properties, mass. As you can see, there's a empty box here. If I select this one, there's a P here. So parameter is selected for mass. One of the output parameter, mass. The other one can be stress and maximum stress. Here we can select as a parameter. So I have two input parameters, the diameter of the top and bottom cylinders, and two output parameters, maximum stress and mass of the whole design. Okay, let's go back, and I'm opening parameters. Oh, by the way, as you can see, because I assigned output parameter, now we have another arrow here. Okay, let's go here. So imagine you want to investigate the diameter effect on your design, those top and bottom diameters. Currently it's 2 millimeter radius for each. Let's go for 1.5, 1, 1/2, half. If you wanted to do this investigation without these parameter studies, it is going to take long time changing those parameters, come back and check the model output parameters. But ANSYS can help us with this. Let's update all the design points. It is going to take a bit time because ANSYS is going to do all the job for us, changing all geometries and coming back and investigate the output parameters, which is here, P3 mass and P4 maximum stress. The first one is already prepared because we solved the previous one, and the other three are gradually getting the results. So we decreased both diameters and the mass decreased, which we expected, and stress increased. And we know because the diameter is smaller, so stress concentration would be higher. That is why maximum stress increased. Okay, done. We can see different by decreasing the both diameters, mass decreased and maximum stress increased. But it's not that much clear. Let's draw a chart. We click here, parameters. Now we can have a chart here. Let's select x-axis for top diameter and 2 y-axis mass and maximum stress. So we can see that by increasing the diameter, mass, which is the blue one, it increases gradually, but for maximum stress, this has a very sharp decrease. So you can figure out a size or the diameter for those cylinders to have after this sharp decrease, because increasing the diameter from 1 to, for example, 2, maybe the difference is less than 2, 5 or 5%, which is not that much, but between 0.5 and 1 it's much bigger difference. So you can investigate different parameters. Let's go back and add one more parameter, like mesh size, because one of the important studies we do is mesh dependency investigation, because your results shouldn't dependent on mesh size, and if you change mesh size, the result difference should be less than, for example, 5%, 3%, 1%. Shouldn't be like a twice or 50% difference. So let's select, for example, this surface, sizing, and let's put the current one. Let me generate this mesh and see. Okay, so I selected this surface as for mesh sizing, and the currently is 0.001, and I select this element size as a parameter. Let's solve everything. Close this one. Go back to parameters. Now you can see we have this element size parameter here. Let's change this as a default, which was 2 millimeter radius for top and bottom, but I'm going to eight six 4. Let's check what is the effect of changing mesh size on the maximum stress. For any design, we need to see this type of study to show your readers you did the mesh independency test and your results are reliable. As you can see, mass won't change because it's not dependent on the mesh size or element size, but maximum stress changes. 0.9, 2.8, 0.9, .2. Let's go one more, this time much more fine. For example, 1, and add to our system. And then I'm going to draw the chart. Okay, it says there's a problem with the mesh. Let's go for 2. Sometimes when you select different mesh sizes, ANSYS can't fit all the mesh with the size you selected in the surface, so it gives you some errors. And the way I selected to refine the mesh wasn't proper way. You need to locally refine mesh at the stress concentration area. But for this case, I just wanted to be to do the simplest way possible. That is why we can see some fluctuations here, which is not acceptable. But let's just check how it is changing. And for Y, stress. Okay, so by increasing, kind of we reach to a minimum and we have some fluctuations. So we need, this investigation is not complete, so you need to refine much more to see what is the effect of the mesh size on the output parameters. For now it's not enough, but as a showcase you can see how you can investigate. Why this study wasn't good enough? Because stress concentration was at several points. I needed selected those several points. Maybe this is not the point I selected to have the maximum stress concentration, but it is good enough. Okay, for you, I would like to do the same. Do mesh analysis using the parameters and send me this figure. How you can send me? You are going to right click here, save image, and wherever you want, and send it to me. Thank you very much.